Okay, we're going to have a look at formulas of substances. First thing to remember is anything in group 1 is going to have a valency of +1, group 2 is going to have a valency of +2, and group 3 is going to have a valency of +3. If you're not sure on that, you need to go back to electronic structures. Then we're going to look at group 7, that has a valency of -1. Group 6 has a valency of -2, and group 5 has a valency of -3. And again, if you're not sure, you just need to draw some electronic diagrams, dot cross structures for those elements, and see if you can work out why that's the case. The other thing you need to be aware of is the fact that some elements go around in pairs. And the common elements that go around in pairs are hydrogen, so we'd write hydrogen as H2. We've got all the halogens. The common ones are Cl2, Br2 and I2. Additionally, we've got oxygen, which goes around in pairs, and nitrogen, which also goes around in pairs. For any of these, right now, you should be able to draw the dot cross diagrams for each of these molecules and prove why they go in pairs. All this information is going to help you to work out balancing equations to make sure that you've got the right amounts on each side. What you then need to be able to do is use those valencies to work out the formulas. The first one I'm going to look at is potassium sulfide, and potassium sulfide is made up of K, and sulfide, the "ide" means just the element is on its own. Potassium is in group 1, so its valency is +1. Sulfur is in group 6, so the valency is -2. First step, we ignore signs, so we can write here K1 S2. The second step is swap them over, so we can write K2, 2 comes from here, and S1, yes, the 1 comes from there. We then drop down, so that becomes, drop down, so that becomes K2 S1, and then the last step is we simplify, so that becomes K2S, and that's the formula for potassium sulfide. Another example, I'm going to look at, keep it up there, I'm going to look at sodium sulfate. Sodium, as you know, is Na +1. Look at the valency. If you look at the valency table, sulfate, the 8 indicates that it contains oxygen, so it's sulfur and oxygen. And sulfate, you'd have to remember this, is SO4 -2. So if we ignore the signs, it becomes Na1 SO4 2. We swap them over, it becomes Na2 SO4 1. We drop them down, it becomes Na2 SO4. Now be careful here, because it's the SO4, we've got one lot of the SO4, and then we simplify, so it simply becomes Na2 SO4. That means we've got 2 NAs here, 1 sulfur here, and 4 oxygens there. Last one. Last one that I'm going to do is quite a complicated one, so if you're struggling with this, I just review the ones that I've done so far. This one is ammonium phosphate. Ammonium you look on your valency table, is NH4 plus 1, and phosphate is PO4 minus 3, and again the 8 indicates that there's oxygen there, so it's not just phosphorus, it's phosphate, phosphorus with oxygen. We ignore the signs, NH1 and PO4 3. We swap them over, oops, NH4 1, PO4 3. We swap them over, so it becomes NH4 3, PO4 1. We drop them down, NH4. That 3, remember, means we need 3 lots of NH4, and the PO4 is 1 lot of that, and so when we simplify we've got NH4 3 times PO4. That's the job done.